Yo, Josh, that road's kind of nice. Let's floor it.
I bet.
Oh, shoot! Oh my
Yeah.
god.
Oh, dude, I need a brake. I can't brake.
Oh my god.
Our project is about how transmission gear ratios affect engine braking deceleration, and we tested this using my 2025 Honda Civic Si with a 6-speed manual transmission. The main idea was to see whether lower gears could create stronger engine braking when the car is coasting and the throttle is released, which is to say, in a lower gear, will my car slow down quicker if I'm not applying any gas?
Our research question was, how does transmission gear ratio affect engine braking when a car is coasting in gear with the throttle closed? We predicted that higher gear ratios, which happen in lower gears, would create stronger engine braking. Because of this, we expected second gear to have the shortest coast down time and sixth gear to have the longest. Engine braking happens when the throttle is released, but the clutch stays engaged. In this situation, the wheel keeps spinning the engine through the drivetrain. The engine resists this motion because of the internal friction and air being pumped past the closed throttle. Lower gears have higher gear ratios, so they can spin the engine faster at the same road speed and create more resisting torque at the wheels. For our experiment, we used a 2025 Honda Civic Si with a 6-speed manual transmission. Each trial was done on the same road. For each gear from 2nd through 6th, the car was accelerated above 50 miles per hour, then the throttle was released and the car coasted in gear down to 30 miles an hour. Speed and RPM were recorded through the OBD2 port using OBD Wiz, and 5 trials were completed for each gear. This clip shows how data was collected during the experiment. The laptop recorded live speed data while the car coasted in gear with no throttle and no brakes. The goal was to measure how long it took the car to slow from 50 miles per hour to 30 miles per hour in each gear.
In the video of us collecting data, you can see Josh turning at the red light, and you can see OBD Wiz opened on his laptop collecting RPM and miles per hour and time to see how fast it takes to go from 50 miles an hour to 30 miles an hour. You can see that it's connected by an OBD2 cable into Josh's car. You see Josh go up to 50 miles an hour, then shift into gear 2, and then taking his foot off the throttle. You can also see Raunit collecting data on the laptop, and you can see the graphs that it's making, how it's collecting miles per hour and RPM. And you can see how fast it goes in second gear from 50 miles an hour to 30 miles an hour. That's an example of our recording.
This graph shows vehicle speed over time for each gear during the coast down from 50 to 30 miles per hour. And basically a steeper line means that the car slowed down faster because in this case it's speed versus time, so the slope of the line would be deceleration, and a steeper line means a higher deceleration. Second gear had the steepest drop, which means that it had the strongest engine braking or the highest deceleration. As the gears got higher, the lines became less steep, showing that the engine braking effect was weaker. Fifth and sixth gear actually nearly overlap, which may suggest that the presence of engine braking is not significant enough to cause deceleration, and what's really happening is the natural road friction, which causes the car to slow down. This graph and bar chart just makes it easier to visualize the actual change in time for the coast down. It shows the average time it took for the car to slow down from 50 to 30 miles per hour in each gear. Second gear had the shortest average time at 10.76 seconds, while sixth gear had the longest at an average of 17.45 seconds. We calculated the standard deviation using our different trials, and if you look at fifth and sixth gear, the error bars actually overlap, which again implies that there isn't a significant change in coast down time at such a high gear. The raw trial data also shows that each gear followed the predicted order, which meant that coast time increased as the gear ratio decreased.
We claim that a higher gear ratio causes stronger engine braking, and our data supports this claim. For example, second gear had a gear ratio of 125 and averaged 10.76 seconds to slow down to 30 miles per hour, while sixth gear had a lower ratio of 41 and averaged 17.45 seconds to slow down to 30 miles per hour. This shows that the higher ratio gear slowed the car down way faster. Our reasoning is that when the gear ratio is higher, the engine spins more for each rotation of the wheels. That creates more internal resistance inside of the engine, which sends a stronger torque back to the wheels. Because of all of that, the car decelerates more quickly, so the coast time is shorter. One limitation in our experiment was road grade. Some of the opposite direction runs of the road coasted way longer because the road had a downhill slope, which reduced the measured deceleration. We first noticed this during the second gear trials on the first road. So after switching direction and realizing the slope was affecting the data, we did not continue using those opposite direction runs. Since they did not accurately represent the engine braking alone, we excluded them from our averages on our data and graphs. For our next test, we would repeat the experiment on a flatter road and run paired trials in both the directions. Then we could average both directions together to cancel out the effect that the road grade has on deceleration. We would also add a neutral coast test where our car is out of gear so we could better separate engine braking from drag and normal rolling resistances. To wrap it up, our results supported our hypothesis. Lower gears in the car created stronger engine braking. The coast down time increased from 10.76 seconds in second gear to 17.45 seconds in sixth gear, almost a 7-second increase in time, meaning second gear slowed the car down the fastest and the sixth gear slowed it down the slowest. Overall, this shows that gear ratios have a clear effect on engine braking, with lower gears creating way greater deceleration.
Oh
my
What
god!
should I do?
Shift down to gear 2 for the highest
Oh
gear
my God,
ratio.
I'm slowing down now.
Oh my
Holy
god.
physics.
Engine braking is so
Dude,
helpful.
That's so cool.
Wow.
I hope my transmission isn't fucked.
This is amazing.
Dance with my dogs in the nighttime. Trap nigga with the chickens like Popeye.